All right, perfect. So, hi everybody, Drew Miller here. Today I'm going to be your service mesh therapist. And what I want you to do is we go through these slides because you're like, what is this whole mesh thing and how do I maintain my security? We're basically going to give you opportunity to relax a little bit about how big and seemingly large of a problem this is going to be, security with APIs in your service mesh. So a little bit about myself. I've been around the block a while. I think it's important for everyone to know why you should listen to someone or what their experience means for possibly helping you solve your problems. So effectively, I've been kind of like that gray hat guy and the black hat in the early days, and ever since the 2000s, really focused on being that white hat hacker and helping everybody out. Around 2008, we really did feel that application security was solved. And I say that in a funny way because it's 2024 and we're still here. So let's go through what we have prepared for you today. And we're going to hit this pretty quick, so let's do it. Okay, let's dial the way back clock. Why were things so simple back in the day? Why was security in a way easy? Were there exploits? Absolutely. But securing it was pretty easy when we think of things in terms of a mesh versus the old days because I'm on one box, I deploy my code, it's one place, it's easy to debug. Effectively, we have these key parts of HTTP, and there's lots of other types of APIs, but we're looking at HTTP today specifically in the examples. We have our URLs, query strings, headers, payloads. We have all this data going back and forth, and we basically want to make sure that we don't have any types of exploits. So what happened is over the last 20 years plus, almost 30 years now, we basically, for accessibility and scalability, we expanded how we process that request from one server and we just pulled it out. So now we have different layers that process different parts of this request, all the way back to some fulfillment. And when we get to that fulfillment, now we have more fulfillment. We have now other APIs we want to call. We have other things we pull in. We have to figure out where we put our data. What does it look like today? Looks like this. It is an absolute mess. We have a lot of dependencies because we have so many things that we want to deploy. And while we do all of our planning and we follow Agile and we get that nice beginning out there, and then we look at it and we say, great, let's go to market. Let's open this up to consumers and to our customers. And then, as I say here, 9 months after, you've had outages. You have 156 user performance impacting defects. Why? What's happening inside your mesh? It's because requirements are changing, needs are changing, and constraints are changing with your providers, with your own systems, with cloud mechanisms that you use, and your own staff and personnel. You have all these teams. I'll read the slides in this case. You have different definitions of done. This is a critical issue across any type of mesh where we say, hey, I want to be able to just call so many things and I just want to provide the service. Like, why is providing this one service so hard to my customer? And it is because of the complexity of the problem. The complexity is the thing that you need to contain, understand, and then manage. To do that, you need to understand this concept of transit carrier. A transit carrier can be modeled after similar ideas of a human carrying a virus or a flu and transmitting it. The idea is you have some type of protocol or payload or some type of data coming in, and the receiver of that isn't going to process it. They aren't going to validate it. They're just going to pass it on. And we have, as we expanded how we process APIs at scale and worldwide meshes, we now have this processing that happens at these different points. Now, because of that, you have to understand inside of your service mesh when and where you're going to pass for any and every API, when you're going to pass data to a downstream consumer that you are not going to validate inside your system. If you're not going to validate that, you're going to pass it off, then you are effectively a transient carrier. You're allowing that to happen. Now, the opposite of that would be validate everything for every possible request, every potential query, and every argument at the edge. And if you think about the complexity of that, you're like, well, Drew, I can't ever do that. So is it okay to be a transient carrier? How do I manage this complexity? Generally speaking, we say, hey, be a transient carrier. It's okay to take data and pass data through your environment in to a degree that is in fact you haven't validated it yet. You don't know if it's good until it gets to some fulfillment location or gets to a system that does header validation or gets to the system that says you haven't authenticated, we're going to send you off to authenticate. Realize that it's okay for that data to move in there, but you just have to know when you're doing it. So two specific cases here. Obviously validate only arguments I need to use. That means you're passing everything else on. You are a transient carrier. And even if you're saying, I'm going to pass it on to child processes, um, then you're also doing it. A couple points here that I prefer always to allow transient carrier because I like having a client server deterministic relationship. Basically, do not allow clients to be authoritative, but you have a relationship in the mechanisms by which the encoding language and content is intended to be transmitted. And that way, when you actually see deviations in it at your fulfillment, you can perform different types of validation. That validation lets you know how to fault early, fault as soon as possible within your service mesh when you are having to process data or pass that data on. So if you consider this for a moment, okay, you have a mesh, you are going to have performance impacts because you're going to have to change things. And the number one most largest basically impacting issue by which a customer will provide a complaint will be for performance. So how do you ensure this performance? Out of the gate, you have to do performance testing. But if you do not have the appropriate validation, considering your transient carrier, perform the appropriate testing to understand where you will fault, and how you will scale, then you will get to the market and you will have performance problems or scale problems. So how do we try to avoid that in your actual planning and execution? Why you're going to have data owners, you're going to have code owners, and you're going to have test owners. So this is the part of the therapy today where everyone can just relax for a second and say, it's okay. And all right, moving on. So your data owners, they're going to actually tell you what is valid data. If you go back technology-wise to databases that had picture format requirements or different forms of different technologies that said, you have to do this. Those felt strict. They felt very much constrained. And now we have these open standards where it's just like, hey, I can put anything I want. Nested structure, infinite base 64, nested encoding in my JSON payload. Well, you still have to be able to validate at some point inside fulfillment. So we need the data owners to really be looking at how you're going to manage, store, retain, and process all of this data, including potentially data that you don't want to carry as a transient. In those scenarios, that definition now immediately becomes the requirements that flow down to your code owners and your test owners. Obviously, the code people are implementing this, and the test owners separating that out basically makes it so that the person who's writing the real code to perform fulfillment is not the same person writing all the test code. They can't just say, the test worked. You actually have people whose jobs are to say those tests work. Now, because we're just talking about very specific deterministic data systems, you can actually use AI to generally just write the validation, find optimal schemas, help generate the code, and write the unit tests. So I recommend that people who have these roles actually experiment with and work with and understand how to use generative AI specifically for those purposes. Realize that you kind of have to know what you're doing to use generative AI to get the right answer because you have to be able to validate that. So while these tools are in fact supportive, they don't necessarily replace any expertise. Now that we basically are saying we're going to have some transient carrier scenarios. We're going to have some data that ends up in the mesh that's bad. We're going to validate it at fulfillment or expect that it's validated downstream and that it's validated as soon as possible so that we fail early. we now have the ability to say, based on the language, encoding, and specific response codes and content payload, including DOM update payloads, everything in a thick application, basically any type of current day application, regardless of complexity, and smartphone applications that utilize full asynchronous updating have the ability to perform that validation of that content. You just have to do it. So this really is a choice. And if you look at incredibly secure platforms, you will see that they have explicit relationships. They do not allow authoritative clients, and they have validation at different places. Could you do that as soon as possible at the edge? Again, it's going to be dependent upon your performance requirements. So you will have edge latency if you try to do absolutely everything at the edge. So inside of this model, we basically say, hey, I'm going to walk you through this 5 steps. You're going to do the requests. You're going to have your cascading nodes validate parts of the request. So it's not necessarily everything at every point. Obviously, there might be places where you can optimize that. And if you can, great, do it as soon, remember, as early as possible. Obviously, if the validation fails, you're either out of sync or you are fielding a malicious request that was made outside of the client. In every one of those scenarios, you're going to have a try catch, you're going to have a fault, you're going to have an else, if else. You have the ability to then know I'm under attack, here's why I'm under attack, or you have a client desync issue. If you have a client desync issue, you could say, hey, well, let's make sure the client's running the latest, greatest software. You could have a hook there to then push that. I would then realize that you might need to do that at different points from inside your service mesh. So again, be thinking at scale about how many points you have for dependencies across client and server-side interfaces and the data components. Don't exclude the need potentially for egress filtering, egress controls, and egress security from your service mesh, because just because someone can make a request and you have other APIs that you have a dependency upon doesn't mean you won't have third party or supply chain potential vulnerabilities, 0 days that affect your need to turn on or off different interfaces within the system in production. I call out here under availability the need for people to be honest. The honesty portion of this is be realistic about the testing that you have performed for your availability. Don't be in a position where actual scale causes you to go, oh, we didn't test that, or oh, at scale, this isn't going to work. We definitely want to be in a position where you're honest about that. Everyone wants things to just be up all the time and scale, scale free, if you will, and just work at whatever scale they need to work at. The honesty there is through testing and validation and understanding your scale metrics so that you can say at a certain point it's going to break. We know it's going to break here, and generally that's okay. You just need to be able to know when that is and ensure you can respond to it appropriately. Okay, so I know I'm kind of cruising through this. There's lots of things to say. So um, basically, you need to use your edge defenses when they're appropriate. We're always going to have the authentication and authorization that happen, and then you're going to use your CDN. Now, this seems like a no-brainer, and it is. You have to use these technologies. But inside the service mesh component itself, you basically are going to have the infrastructure of the service mesh, and then internally you're going to deploy effectively a distribution of functions and data locations that is a potentially logarithmic or exponential complexity issue. So you need to know the routes, the logical routes between the APIs and how those are going to work. You're going to test it at scale and you're going to implement effectively these types of relationships. The determinism component basically ensures that all the clients, and let's talk about the clients for a second. These could be API automation, service accounts, or different things like that. You may have a need to actually allow just a single API that gets called off of a token that lasts for a very long time. So how you actually process your expirations, things like that, all of these things need to come into account on how you're going to do testing and long-standing delivery from basically any type of a mesh. there's a lot of thought that goes into the build or buy concept for absolutely everybody. I say here, start caring about the frameworks you use. It's one thing to just grab something and say, well, this uses Entity Framework. I'm never going to have a SQL injection. But do you really know that? Have you dug into it? Are there calls that maybe don't use the Entity Framework or do some type of specific SQL injection protection at that one query, the one that you don't know about? So the frameworks themselves, as you deploy into something like a service mesh, especially if you're embracing cloud scenarios of infrastructure as code and automating a lot of your rollout with containers, there's just a lot of complexity here. So dig into each one of your frameworks, understand the features you're going to use, understand basically the parts that start, that trigger activity to happen, and make sure that your attack surface, both externally from your service mesh, especially if you do authentication, a lot of your work outside of that, as you push into the service mesh, you're going to basically just be dealing with transient carrier issues. And then your validation and erroring that will continually occur there, because you will see those constant errors, have unique information that you can use to then trace back into a unique API, a unique location inside your service mesh, a specific cluster, and so forth. So be thinking about those ephemeral components as well, and understand how the ephemeral components are actually going to impact your overall debugging strategy. Because if you build something and it scales and stuff breaks and then it goes away, how are you going to debug that? So you need to be thinking about these ahead of time. Make sure you're testing at scale as well. My last point here is stop blaming others. I think that if we want to be um, in a place where we understand the risk and resolution that we provide for whatever our jobs are, whether it's as leaders or as developers, is to be sure that you understand the scope. And obviously, this sometimes is a fight, right? It's a fight of saying, hey, who's responsible for these parts? Stand up, own those parts, and then drive them to their logical computer science conclusion, their engineering conclusion. A lot of times, if you can avoid the politics and focus on quantitative outcomes, you can actually achieve security and show performance both from a secure perspective and a functional perspective. And one last thought here is oftentimes you'll have two teams, and one team might actually be the root cause for a vulnerability, but the other team's getting blamed because it's through their interfaces that you actually see the exploit resolved. So you have to consider in these multi-team scenarios that change control, that data ownership, code ownership, those contracts between teams also show how you're testing between the teams to ensure that the responsibility of code changes that has cascading impacts is both considered, but then respectfully, the teams are I don't want to say held accountable, but effectively we know where we need to improve in terms of code quality. So I'll leave a couple moments for questions.
There we go. Drew, thank you so much, man. I always learned so much from you. I really appreciate it. We actually had some questions that were flowing in during your talk. So I'm going to throw a few up here. I mean, some people I know and love. Mary, great to see you here. Had a question around what is a DOM
Sure.
update payload? I don't know that either. So,
All
Mary,
right,
I'm right there
sure.
with you.
So the DOM is the document object model, and inside of XML style framed documents, of which a web page would be an HTML document object model. The code inside the browser can be used to call a remote server, get data like a new frame with dynamic content, like an ad, and it can pull it over into your browser, and then it can update your browser. And that's updating the document object model is the actual technical function that happens. And so then all of a sudden, you see this ad that has appeared in the screen. That's a DOM update. And so we see across pretty much any level of dynamic exploitation that occurs between websites. We see these requests that go out, and then obviously when the response comes back, if the browser code doesn't properly handle that, then you can see exploitation.
Um, Thank you for that. Another friend of mine. Hey, Tony, good to see you as well. What guardrails are there in the event service mesh fails or is misconfigured?
The guardrail for catastrophic failure is have multiple environments, have known good environments, and actually be able to dynamically push and update and scale those out. So if you think of the entire thing failing at once, well, you probably need to have some region redundancy. Like you need to approach redundancy at the network layer, at the application layer, at the cloud layer, and so forth. What we would typically do, and this is important part of that, like let's say that you have something fail that is a part of a cluster that is due to, let's say, a vulnerability, and you're trying to fix that, you're trying to push something out. Um, then let's say you turn off one of the components of the cluster and you push that change just to that one and turn it back on. If you start thinking about how you would roll out while you're in production fixes to components at scale, you'll find you'll slowly be checking those boxes across everything you're asking for, from just one app service that has failed to now, how do I patch schema on databases and production environments? How do I move quickly to do those? So catastrophic failure, you would reboot, probably move a QA, basically a background mirrored environment, and you would redeploy and connect to replicated data. You basically would execute the disaster recovery BCP plan, which you should have before you go production live with your mesh. Sorry for the long answer.
Yeah, no, and maybe there's a follow up here from Tony. Hopefully that was helpful. Um, how about this here, Drew? What about using IP subnetting and L3/4 firewalling?
Well, I would say that, obviously the network parts of your entire deployment are critical. So you should consider everything regarding scalable devices in cloud, in terms of how you're doing your content delivery network, where you're actually going to do your fulfillment with the failover. And then from a firewalling perspective, there's advanced firewalls today that'll give you layer 3 to layer 7 with an introspection and application security features. And of course, you have WAF and other tools that exist for that.
I see here How has asked if we could show your this last slide here. How, if there's a specific question that you had in mind, I think maybe a lot of folks just very keen to capture some of the great content here, Drew. And yeah, lots of people asking for recordings and all that good stuff.
Yeah,
So
let's make sure that we get the slides to everyone, and then I'll say here, and hopefully I don't get in trouble, Dan, is if everyone just sends Dan a lot of spam, and if we need to reboot, application self-defense, digital self-defense for API sec, and get down into the weeds on some of this, let's do that. So we have
yeah,
support.
I'd love to feature you on a webinar or something, Drew, because there's definitely a lot here, and really appreciate your expertise here. So let me see if there are any other questions coming up. Nope, looks like we're good. So Drew, thanks again, man. Really appreciate it. Your expertise is always super valuable. So we're gonna move you off here and get ready for our next one. We got a few minutes yet, so see you later here,
Take care,
Drew.
everybody.